In this lab, I'm going to be performing a series of different reactions, and what you are going to have to do is to figure out the reactants and the products, writing word equations and balanced chemical equations, and you want to record thorough observations for each type of reaction, and you also want to be able to determine the type of reaction. Is it single displacement, double displacement, synthesis, decomposition, combustion? So we'll have to use our notes from our previous learning in order to do this consolidation lab sheet. We are going to be taking some pieces of zinc metal, and zinc metal, as you can see, they are some solid silver hard pellets. And I'm going to take some hydrochloric acid. This happens to be 1 mole per liter hydrochloric acid. We're going to pour some of that into our test tube. We're going to add a couple of pieces of zinc, and we're going to stopper that test tube. Now you can see the reaction there, producing some gas bubbles, and it seems to be quite vigorous, so it's quite fast. What we're going to do is we're going to test that gas. So I'm going to get a Bunsen burner lit. We're going to get a burning splint. Okay, let's test the gas. And you hear a little bit of a pop. In this reaction, we are going to take some sodium chloride and we're going to take some silver nitrate. Both of these are clear or transparent, colorless liquids, and we're going to add them to a test tube. So we'll start off with some silver nitrate, and then we will add some silver chloride. You can see the results of that experiment. In this next reaction, we're going to take some copper 2 carbonate, and copper 2 carbonate is a green powder, solid. And what we're going to do is we're going to heat that up in a Bunsen burner flame. Turn that down a little bit. Grab our tongs, and we heat on an angle, okay? So we're going to be heating that. You're going to notice that there's some vapor coming out the top there. So that means we're also creating a gas, and we're going to test for that gas, but you should be able to notice what's happening to that green powder in the test tube. Okay. And while that vapor is coming out, I'm going to test for that with my burning splint. Let's get that going. And we're going to test. And I notice that it puts my splint out. In this experiment, I have some aqueous copper 2 sulfate. What I'm going to do is I'm going to take some steel wool, which is primarily iron, and I'm going to put that into the test tube, and then I'm going to come back in a couple of minutes and see what happens. Okay, here is the reaction after about 3 minutes or so. You can see this was the liquid beforehand, and you can see a change there as well as a change in the iron. So we definitely have clues of a chemical change happening. You just need to determine what type of reaction that is. The lab technique that I'm going to perform for this next reaction is called the downward displacement method, and this is used to collect gas. So what I've got is a beaker half filled with water, and then I filled a test tube with water, and this inverted test tube is inside of the beaker. And what I'm going to do is I'm going to create some gas. I'm going to put a piece of calcium carbide into the water to create acetylene gas. You're going to see that it's going to start to bubble right away. What I'm going to do is I'm going to collect half of a test tube of gas. So you can see that it's bubbling. I'm putting this over top and you can see some gas. Now I'm going to lift this up and out, and then I'm going to stopper that test tube. So what I did in that reaction is I've got a test tube now that's half filled with acetylene, which is C2H2. It's a type of fuel, and the other half is air. What I'm going to do next is light a Bunsen burner, and I'm going to light a splint, and I am going to test that reaction. So here I have a burning splint, and I'm going to put that into the mouth of the test tube. And there's our reaction. So we had our fuel, C2H2. I had an ignition source where I was lighting the fuel and the oxygen together, and you definitely can see evidence of some black carbon there. So that should give you an idea of the type of reaction that you are getting for that particular combustion reaction. In this lab demonstration, we're going to be doing the downward displacement method. So this is where you have half a beaker of water, and I've inverted another full beaker of water. What I'm going to do is I'm going to take a piece of calcium metal. So here is a piece of calcium metal. And I'm going to drop that into the water, and we're going to see that there is very slow reaction at first, but you can see that it is starting to bubble and it displaces the water. What we're going to do is we're going to collect an entire test tube of whatever gas is being created when calcium reacts with water to help us figure out one of the products that's being made. So as you can see here, that water is getting displaced, so it is moving out of the test tube and into the beaker, and this test tube is being filled. Okay, so gas is being collected. Now that the entire test tube is filled with gas, I'm going to stopper that test tube. And we can see in the beaker, we are getting a white, translucent, thicker material starting to form there. And I want to test the gas. So what I'm going to do is I'm going to get a burning splint ready to go. And we're going to see what this gas is. So here we go. Ooh, you heard a little bit of a pop there. Okay. In this lab demonstration, we're going to take some 1 molar sodium hydroxide solution, that's in aqueous form, and we're going to take some 1 molar iron 3 nitrate, that's also in aqueous form, and we're going to react them together. So let's take a look. We'll start off with a little bit of iron 3 nitrate. And then we will add some of the sodium hydroxide. Okay, and let's take a look there. We see that we have some chunky, gelatinous, darker orange precipitate that has formed. In this reaction, I just have a test tube filled with distilled water, so it's pure water, and pure water is neither acidic nor basic. It just has a pH of 7. What you would have learned in grade 10 are some acid-base reactions, and you would have learned a little bit about the pH scale. I'm going to add a couple of drops of this acid-base indicator, and this happens to be bromothymol blue. So I'll add a couple more drops here. There we go. And we're going to see that it happens to be a pale blue color in the water. What I'm going to do is I am going to use my breath. I'm going to insert a straw and I'm going to blow into that, and we'll see what happens. We can see the color change that occurs when I bubble the carbon dioxide that I'm blowing out into the water.